So in this session, we'll elaborate Hive. So let's discuss one by one. So what is actually a Hive, right? So generally we know the Hive is one of the important tool or important component that is available in the Hadoop environment. Here, the Hive is mainly used as a data warehouse infrastructure tool in the Hadoop environment. Okay, so where here this Hive can process structured data, right? So mostly the Hive environment can process the structured data, and whatever the the data that you are going to process, those data will be residing on top of the Hadoop, and maybe you can summarize the big data and then makes querying and analyzing easy. Okay, so here, since it is actually used as a data warehouse infrastructure, this data warehouse infrastructure is mainly meant for analysis purpose. Okay, so there is a basic difference between the normal RDBMS and then data warehouse environment. In the normal data warehousing system, RDBMS, in the normal RDBMS environment or in the software, generally we'll get the data from a single source. Okay, any transactional data sources will be getting the data, and will be storing the data in the RDBMS related databases. Okay, but whereas when you see the data warehouse, you can get the data from different sources. Okay, that is the key difference between the RDBMS and then data warehouse. Okay, so you can get the data from multiple sources, and then you'll be saving all the data in the data warehousing environment. Okay, so then when you save the RDBMS, when you save the data in the relational database management system, mostly it will be in the form of recording purpose. You'll be saving the data and you'll be retrieving the data whenever it is required. Okay, but whereas when you are going to save the data in the data warehouse related environment, you can take it for analysis also. Okay, so that is why the difference between the RDBMS, you can perform OLTP, that is online analytic, that is online transaction processing, whereas in the data warehouse environment, you can perform OLAP, right? So here in the Hive environment, you can see some mix-up features of data warehouse as well as the RDBMS. Okay, so here in the data warehouse environment, you are mainly using the structured data, and suppose if you want to use the unstructured data, maybe still you have to convert your unstructured data into the real structured format, and then you can use it. Okay, so there is a conversion required when you use your unstructured data in this Hive environment, and still it is possible. Okay, the people are saying still it is possible to use unstructured data, but again this particular environment is mainly meant for structured data. Okay, so then it is not intended for unstructured data, but anyway, so you can just convert it and you can use it. And so to be very specific about the unstructured data usages, then you can prefer H-based environment. Okay, that is what the point we discussed. And the next one is this Hive environment was developed by Facebook initially, and then this project was developed by Facebook, and later on the Apache Software Foundation took up this particular project and they have developed. Now this Hive becomes the open source. Okay, and what are the main features of Hive? So it stores the schema in the database and processed data into HDFS file system. So whatever the data you are going to store or whatever the data you are going to process with the Hive, it is just going to use some schema based, right? But whereas we have studied in NoSQL databases, the NoSQL databases will be using schema-less. Okay, so when you are using unstructured data and semi-structured data, we'll be using schema-less. But when you are using only the structured data, you have to use some schema. Okay, so that is what there is a relationship you can just imagine, just you can compare, right? So since the Hive environment is using schema-related concept, then you can say it is going to use the structured way of storing it. Okay, so structured way maybe not exactly how the relation database management system is storing. It is storing in the form of column wise or in a big table format. Okay, so it stores schema in the database and processed data. So whatever the data is been processed, all the processed data will be stored, saved in the form of HDFS. Okay, the data storage will be given to the Hadoop environment format. Okay, see, when you are using RDBMS, the data storage will be in the form of simple tables. Okay, so there you'll be using some relational table or some other table format, and simply we are using it. But here the storage wise, when you use the Hive environment, it is actually depending on the Hadoop system, and whatever the data it is going to store will be based on the HDFS file system. Okay, then the next point is it is designed for OLAP, as I told you already. So here, since it is a kind of data warehousing environment or data warehousing tool in the Hadoop system, then you can perform the online analytical processing, right? So whereas when you use, if it is a strictly RDBMS related environment, then you have to use the OLTP, online transaction processing, right? So then other idea is here is we need a high level language, a simple language to interact with your Hadoop system instead of using always Java and other complex, somewhat difficult programming. Okay, so it provides a simple SQL type language for querying called HQL or HiveQL, we can call it. Okay, so here we are going to discuss in the HiveQL or in the HQL language. It is actually mainly it is going to give the same similar type of syntax that we studied in SQL. Okay, so mostly all the syntax and every format is followed based on the SQL, right? So it is familiar and then fast, scalable, extensible, because it is very easy to use. So always no need to go for a bigger language like Java and other type of language to process with your Hadoop environment. Okay, so it is just enough to know the HQL queries to interact with your Hadoop system. Okay, even learning the HQL is also very simple, right? So if you are strong in SQL statement, SQL commands and everything, SQL syntax and everything, so learning Hive or Hive HQL, that is HiveQL or HQL language is very easy, right? So here the architecture of the Hive, we have three different layers. One is user interface, and in between we have the engine as well as the meta store, and finally the HDFS or the H-based data storage. That is what the underlying data store, or how you are storing the data exactly. Okay, so it uses the HDFS file system, and again it uses the H-base as the backing, that is for storing your entire file, right? So here in the architecture of the Hive, it's starting with the user interfaces. You can use different type of user interfaces. Mainly you can use some Hive supported web-based user interfaces to send your queries from this web user interface, and then you can use some commanding. Okay, so suppose if you want to use a HQL command directly, you can use from the Hive command line. And then the one more option is you can interact with your Hive system or in your Hadoop system from the cloud environment. Okay, so there are different possibilities are there. You can interact with your this Hive system. Okay, so here whatever the query you are sending from the user interfaces, that will be processed in the Hive query language process engine and execution engine, right? So here the MapReduce, the execution engine, act as an interface between your Hive query language processing engine as well as your MapReduce process. Okay, and here the meta store, you have the meta store. Since this particular Hive environment is going to get data from different sources, and whatever the data is used in this Hive environment, for all those data, the schema as well as the other structural description should be saved in the meta store. Okay, this structural description or the schema related information will be collected from the sources itself. So from where the data is getting, from the source itself, it is going to get all the metadata related data. Okay, so we know already what is meta store or what is metadata. It is data about data, right? So here what is the use of the meta store or the metadata is at the time of processing your query. So the queries, even the syntax and then semantics, what is the data type you are using, Okay, so since we said it is a schema oriented, so what is the schema? What is the exact schema you are using? What is the column value you have used? What is the attributes you have used? Okay, what is the type of data you are used? So everything will be checked against your the metadata details. Okay, so at the time of processing, what will happen? So when the user gives some query to the Hive interface, that will be processed initially by the HiveQL process engine. So this will be getting the details from the metastore, which has been already saved from the different sources. And this again, it is just going to send to the execution engine for the process, and then the map reduce will be taking place here. So the map reduce, you have the job tracker, and then other the different map and reduce concept, right? So based on this concept only, it is just going to process your data, right? And the next comes to see, it is just going to interact with your Hadoop HDFS and the HBase system. Okay, so just we'll see what is happening in the architecture. So as we said, it is a user interfaces. There are different user interfaces we are using, and then metastore, it is how it chooses to respective data servers. So the Hive environment is going to interact with different data server. From the data server, it is just going to collect all the schema and metadata related details. Okay, so what is the table related information? What is the database related information? Okay, what are the columns are used in the table, and everything will be collected from the different data servers. Okay, that will be kept in the metastore. And again comes to the HQL process engine. So it is similar to your SQL query engine, so that we studied in the RDBMS. Okay, so in the relational database management system, we'll be using SQL. To process with SQL, you have the SQL compiler and then SQL query engine. Okay, then optimization, everything is involved here. Okay, the same thing happens here also. The process engine will get your HiveQL queries, okay, from the user, and then again it is going to check with the metastore for the schema related information, and then the replacement, it is just going to direct your whatever the processed detail to the map reduce. That's what we said. It is actually between the exact process engine is in between your SQL process as well as your map reduce. Okay, so here the map reduce, what the map reduce is doing. So instead of writing your map reduce program in Java, we can write a query for map reduce job and process it. That's what I told you already. So instead of writing Java code for everything, what you can do, you can just simply send your HiveQL queries, and remaining thing will be taken care by the map reduce. Okay. And what do you mean by the execution engine? So it is actually conjunction part of your HiveQL process engine and MapReduce. We saw in the diagram. So you have the HiveQL process engine and then MapReduce. In between, you have the execution engine. Okay. So you need a mapping between your HiveQL process engine and then to the MapReduce. That means whatever the process is done with the HiveQL process engine, the output of the HiveQL process engine will be converted into MapReduce understanding format. Okay. So it is a Hive execution engine, and execution engine process the query and generates results as same as MapReduce result. Okay, suppose if you are using Java language and then you are performing the MapReduce, the same effect, same thing will be done when you use the execution engine. Okay, the execution engine, the role of the execution engine is to convert your HiveQL output into the MapReduce understandable format. Okay, so whatever the data we are getting from the execution engine will be in the form of MapReduce format. Okay, so we already spoke about the HDFS, that is Hadoop distributed file system, or HBase, or the data storage. Okay, either you can use all the data to store really in the databases in the form of HDFS, and then HBase will be also used here. Okay, so in the relational database management system, the final storage will be storing in the form of tables. Okay, so maybe you can use any type of data model, that is the table model or the relational model you can use. So based on the relational model, you are going to save your data, entire data, in the table format, exact table format, or the exact structure format. Whereas here in the Hive environment, whatever the data you are going to store in the final stage, everything will be saved in the form of files. Okay, file in the sense it is actually using a table related format. Okay, so again it is also treated as a file. Okay, and this is actually the working of the Hive. So we maybe so we have just discussed a little bit. So whatever the previous diagram, so that is actually elaborated a little bit here, more here. So you have the interface, that is you will be sending some HQL query here, and then this query will be forwarded to the driver. Okay, the HQL driver, and this driver will be sending the query to the compiler for all type of pre-processing. Okay, the compiler will check for all semantics and syntax related errors, and all the the compatibility. Okay, the parsing, validation, everything will be performed by the compiler. And again, this compiler will be checking with the metastore. The metastore will be having all the description and then the schema related details about the particular data. Okay, so this will be checked against by the compiler, and again the compiler will prepare a query plan. Okay, so here the one of the important thing is the compiler will prepare a query plan, and this query plan will be again sent to the driver for execution. Okay, so maybe you would have studied in RDBMS, in the DBMS subject. So we have query processing and query optimization. Okay, so query processing, query optimization, that is when you are going to process your query, the query before it is going for execution, a plan will be prepared. Okay, that is query plan. Okay, based on different strategy, a query plan will be created, and among the query, the different plan, a optimized plan will be selected. Okay, so that is what we call as a query optimization, right? So before any particular query is being processed, then there will be different, the plan will be prepared. Right. So say when you are writing any SQL statement or even in the HQL related commands, so the same command will not be executed as it is. Okay. So based on the conditions, based on the schema, and based on your join operation and other relational algebra concepts, everything is involved here. Okay. So based on some background related ideas, the query will be reframed. Okay, so that's what we call as a planning. Okay, the plan will be created here, and then there will be multiple plan will be generated, and then based on the effectiveness, based on the performance, a suitable plan will be chosen. Okay, that's what we call as a query optimization. So the same thing happens here also. Here in the compiler is generating some different plan for execution, and this driver is getting the appropriate plan. Okay, so up to this the compilation will be over, and then once the query execution starts, the execution engine will take the particular query with a proper plan, and this will be sent to the MapReduce and HDFS system. Okay, so the execution engine is actually an interface between your MapReduce and HDFS and to the remaining system of your HQL. Okay, so it is actually the interface, right? So there is a communication point between your execution engine to the MapReduce and HDFS component, right? So here you have the execution engine. This execution engine is sending the whatever the plan or whatever the query is generated, and this will be sent to the job tracker. Okay, so this job tracker is actually the one main component of your MapReduce system. And here this MapReduce, the job tracker, what the job tracker will do, it just forwarding the query into map and reduce concept. Okay, so here the query is processed, that is the execution engine is processing your query, and the processed query is sent to the job tracker, and this processed query will be again executed in the form of map and reduce, because your query and the entire system will understand only in the form of map and reduce. Okay, so even if you write any Java language code, and after this map and reduce concept only, after implementing this technique only, the HDFS system can understand. Okay, so before you interact with your HDFS file format, and the map and reduce should be done. Okay, so here based on the query, executed query, so the task tracker will perform the map and reduce task, and then this will be forwarded to the HDFS name node and data node. There are two different nodes are there in the HDFS file system, the name node and data node. So name node will be keeping track of all the name related from the data that is available, and data node, the exact data will be present in the data node. Okay, so there will be a connectivity between your name node and then data node in the HDFS file system. Okay, so mainly the HDFS file system uses this technique, that is name node and data node. Okay, so here once the query is processed, and based on the query, it is just going to get the data from the data node. Okay, so based on the query, HQL query, the entire file system will be processed, and the exact data will be picked up from the data node. Okay, so then what is happening here? So after getting the correct data based on the query given, then again it is getting back to the MapReduce technique, and here whatever the data is obtained, that is performing the reducing. Okay, it is just narrow downing the data that is obtained. Okay, so the first one, when it is going to enter into the HDFS, it is performing the mapping process. Okay, so after getting that exact data from the data node, it is just again getting back, and it is performing the reduce. Okay, reduce concept, it is just going to summarize in the form of, in the simplified form or in the result based form. Okay, so after reducing, it is again getting back to the job tracker, and the query or the result will be forwarded again to the execution engine. At the time of the execution engine, what it will do here, maybe it is just checking with the meta store. Okay, so even before processing the query as well as after getting the result, and after getting the result, it is just going to get your final result to the driver, and this driver will forward the final result back to the interface. Okay, suppose if you are using a web related user interface, and you will be getting the result in the same interface itself. Okay, it is depends on how you are designing your interface. Okay, suppose if you are using a command line, you have send a HQL query, and in the command line itself, what is the data, what is the output, you will be able to see there. Okay, so this is how the Hive environment is working. Okay, it is say the input will be the Hive query language command, and after this, the remaining process and all, how it is happening in the RDBMS query processing. Okay, the relational database management system, how the query is being processed. So the same thing happens here with some small modification, and so you can see all the steps here. So like it is sending to the compiler will do the performance, do its task, and then it refers the meta store, getting back the appropriate plan of the query, and again it is forwarding to the driver, and this driver will be sending again back to the execution engine for execution purpose. Then this execution will be converting your query into executable format, and this will be forwarded to the MapReduce and then HDFS system. Okay, so after getting the correct result data from the data node or from the HDFS file system, this will be again taken back to the reduce process, and this again the job tracker is forwarding back to the execution engine, and from the execution engine, the driver is forwarding back to the interfaces where you can see the exact output. Okay, so this is how your Hive environment is working. Okay, this is what all the explanation. So working of Hive, executing the command and getting the plan. Okay, and how you are getting the metadata, right? So what is the use of the metadata, right? And then how you are sending the metadata, okay, response to the compiler, and then what is the plan. Okay, so based on the query, the plan will be created, right? And then it is just going for the execution plan. The driver sends the execution plan to the execution engine, right? And then the execute job, so it is actually executing the job in the form of MapReduce. And here you have the metadata operations. Meanwhile, in execution, the execution engine can execute metadata operations with the metastore. So at the time of execution also, it is just going to get the details from the metadata or the metastore. And when it is fetching the result, it is just going to get the data from the data node. Okay, so in the HDFS system, you have the name node and then data node. So the data node will be having all your exact data. From there, it is just going to get the result, and this result will be forwarded. Okay, so that will be execution engine sends those resultant value to the driver, and finally it is just going to give you the result. Okay, so driver sends a result to the Hive interfaces. Right. So the next topic is Hive data types. Okay. So more or less, hereafter what we are going to study, it will be very close related with the SQL. Okay. So the syntax and then data type, everything will be more or less similar to your SQL. Just will move a little bit faster. Right. So here column types, literals, and null values and complex types. There are 4 different types of data types are used in HiveQL. Okay. And then the column types, suppose if you say in the column types, you can see integral types and then string types. Integral, as you know, or integer type, you can see there are different varieties of integers used here. That is int, big int, int, and then small int, tiny int. Okay, there are 4 different versions of integers are used here. So here integer, it is actually when you have a range exceeds the range of int, maybe you need to go for big integer. So each and every category, each and every type of integer will be having certain range. Suppose it is based on the data. Suppose if you are using certain, the data that is beyond certain limit or based on certain range, you can, consider or you can use any one of the type of the integer, right? So big integer, it is a bigger one. And then again, if it is small integer, it will be a medium one. And then suppose if you are going to very, very small, and then you can use the tiny integer. It is based on the size of your integer you are using in your application. Okay. And then string type, as usual in the SQL, it can take both single quotes, within single quote and then within double quote. And varchar, maybe you would have studied in SQL, varchar and character. Okay, so and then one more, you have the C types, escape characters also used in the string types. And timestamp, as you know, the time as well as the time, maybe along with your date. Okay, date and time, combination of date and time. The format is year, month, date, hour, minute, second, and then the one more precision is added here, nanosecond. Okay, so that is what only difference is here in the timestamp. You are having nanosecond also, right? Date as usual, year, month, and day, right? And then decimal you can use here. Decimal is a big decimal format of Java. So here you can see it is a combination of whatever the data type you're using. Mostly will be related with SQL data type as well as the most compatible with your Java data type. Okay, so then it is used for representing immutable arbitrary precision, normal decimal values. Okay, then union. So one more special type of data type you can use here is a union. Maybe you would have studied about structures and unions, where if you want to store different types of data type in a single unit, you can have a union here. Okay, it is a collection of heterogeneous data types. Suppose if you want to combine integer, string, and then other date format or any other things into a single unit, then you can make it as a union. Okay, so you can create an instance of the union and you can make use of it. Okay, it is how you are creating a union variable and then structure variable in the C and C++. And literals is actually a kind of value, a floating point types and then decimal type. Floating point, as you know, with decimal values or with fractional values, you can take it here. That is, you can use it along with the decimal point. Here double is the word, you can use it for floating type. And then one more decimal is there. This decimal type is even very higher than the double data type. Okay, you can see the range of decimal type. It is about 10 power minus 308 to 10 power 308. Okay, so we maybe will not come across this type of range anywhere. Okay, so if you see 10 power 308, just imagine the range. That's why we handle with the such huge volume of data. Okay, so the size of data. So maybe you can just imagine from this. And complex types, So there are different complex types of this. It is actually again mostly related with your Java types. Suppose if you studied Java, you can easily understand this. Okay, there are different complex types of used here. Arrays, and then map is there, structures is there. Okay, so map, list, collection classes. There are different complex data structures we use in the Java, right? So arrays, as you use arrays in the other language, even in the Java language, and you can declare like this: array is a keyword and then the data type. Okay, so and then map in Hive or similar to Java maps. So whatever the map you are using, it is similar to your Java map. Okay, so map, list, map will be mostly having your key and value pairs. Okay, so map, there is primitive type and then data type. That's what the primitive type is there, and then data type is there. And then structure, again you can use in the place of union, you can use structure also. And then in the structure, one more thing, you can add your comment. Comment is also you can include in the structure. Okay, structure, and then what is the column name, and then data type, and then comment is column and then comment. Okay, so one more thing is to get your details about the data that you are using, you can use one more comment. Okay, so how you can create the database, it's all similar to your SQL statement. Create database, if not exists, user DB. User DB is the database name. And then the the example is create schema. You can create your schema also. Okay, then show databases, like we use your like describe, those type of command we use in the SQL. Similarly, you can use show databases. Okay, and then dropping the database, drop database. Maybe if the database available, it is going to drop, and then drop database user DB cascade. Suppose if your database is connected with the other tables or another databases, you are going to drop the databases one by one. Okay, using the cascade. And drop schema and then user DB. Maybe suppose if you want to totally drop the schema, then you can use this particular command. And create the table. It is an example how you can create a table. Create table if not exists. That is option 1. So comment and then row format. These are the other parameters you can add. Right. So you can see example here: employee, EID, INT, name string, salary string, and then destination string. So this is how we'll create a table in SQL queries. Okay, the same type of format we are using here also. Then one more thing is we have SQL that is Hive partition. That is what the main topic we have in our syllabus. That is Hive sharding. Okay, Hive sharding. So we will discuss later in the next classes. Okay, so we'll talk about more detail about Hive sharding in the next class. Okay, so partitioning your tables. Okay, and this is how you will take your table. This will be a simple example how you can create your table, and then a select statement. Okay, so this exactly same as your SQL statement. Select star from employee where salary greater than some value. Okay, and select order by. Maybe suppose if you want to group, that is order by. It is actually a kind of sorting method, where if you want to order, that is arrange your output in the one particular data type, that is one particular column, department. Okay, so select group by. Group by is also used based on a particular group. You can get the details. Select department, count, that is you are going to get the number of records available, number of data available from the department. Okay, so in this session we'll start with HiveQL joins. Joins, maybe you would have studied in normal RDBMS subject or DBMS subject. So here join, when the join is required, suppose if you want to combine more than one table with some certain conditions, then you need a join concept. Okay, so here the join clause that is used for combining specific fields from two tables by using values common to each one. So at least you should have a common value on both the tables. Okay, it is more or less similar to your SQL join. That means maybe if you study the normal SQL join, those concepts you can apply here also. Okay, so in the normal SQL join, we have studied different type of join, starting from the inner join, outer join. Okay, so in the inner join, you have the theta join, EQ join, natural join. These are the three types of join comes under inner join. And in the outer join, you have the left outer join, right outer join, and full outer join. Okay, so there are different type of joins you can perform. The same thing you can do here also. In the HiveQL language, you can perform the join operation like this. Generally, join, you need two basic operation, okay, to perform the join. It is just nothing but performing the Cartesian product first and then performing the select operation. Okay, so we maybe you have studied about select project, okay, and then relational algebra, those type of concept you have studied in SQL. Select, we use the sigma symbol. Okay, it is functioning more or less equivalent to the select statement. Okay, the select operation will perform in the horizontal manner, and in the project will be performing in the vertical manner in the table. Okay, so here to perform the join operation, first you need to perform the Cartesian product, and then after the Cartesian product, you will be performing the selection process. Okay, so the combination or maybe the Cartesian product followed by the selection process is join. Okay, so when you perform the join operation, based on different conditions, we'll be doing different types of join operation. Okay, so now you can just see here how the Cartesian product is doing. Okay, so you have the two relations R and S. Here the relation stands for the table. Okay, so R and S. This is a table 1 R. That is, this is a table S. Okay, so you have the two tables. When you perform the Cartesian product, R cross X. Okay, so the R cross S, first what you will do, you first take the first record of your first table. Okay, first record of your first table, and you will multiply all the records in the next table. Okay, so then you will take the second record of your first table and you will perform the multiplication, that is combinations of production of all the records available in the second table. Okay, you can see in the result here alpha 1 alpha 10a, alpha 1 beta 10a. Okay, then alpha 1 beta 20b, alpha 1 gamma 10b. Okay, so all the four sets you are getting here, and then here one more, the next record you are picking up from the first table, that is beta 2, and then alpha 10a, beta 2, beta 10a, beta 2, beta 20b, and beta 2, gamma 10b. Okay, so when you perform this type of the product here, this we call as a Cartesian product. Okay, so before you perform the join operation, first you need to perform the Cartesian product so that you will get all the combinations of your both the table, and then from this, based on the conditions, okay, maybe the condition may be anything. So based on the conditions, you are going to apply the conditions on this Cartesian product result. Okay, so here you can see what are the different type of joins you can have here. You have the inner join. That means the innermost point. That is, you are combining two different table and you are making it as a relationship between two table. Okay, so this is what we already said. In the inner join, you have the EQ join, theta join, and natural join. Okay, so if you perform equal symbol, if you take two record, that is two values equal, if you are comparing two records, whether it is equal or not, then you can say it is a EQ join. Suppose if you are other than the equal symbol, if you are using any other relational operator, greater than, less than, greater than or equal to, less than or equal to, then you can call it as the other theta join. Okay, theta represents the other all relational combinations. Okay, the natural join, so you don't need to compare anything. So with the available exact matches of your data, which is available on both the table, you will perform the join operation. Okay, so just you are performing as just in the natural way, right? And here in the full join, this is another type of join we are going to perform. So this actually inner join, this is outer join. Okay, full join is combination of both, and here left join and right join. So there are different types of join you can perform here, right? So mainly we are going to talk about the left outer join, right outer join, and full outer join. Okay. Now, so let's discuss about a simple query, how you can write a HiveQL query for join operation. Okay, so you have the select c.id, c.name, comma, c.a. There are three attributes you have picked up from the first table. The first table is customers. Okay, so then the second table, or that is amount, only amount you are taking from the second table, amount from, and then customer C, join orders O on. Then you are comparing two values here, c.id equal to then o.customer id. Okay, so here you are using two tables, customer and orders. Customers you are using letter C, and then for orders you are using letter O. Okay, that means you are using alias name. We call it as a alias name. Okay, instead of using the complete full table name, you'll be using the only the alias name, which is in the shortest form. You can make use of it. Okay, instead of typing the table name every time, you can make use the alias name here, right? So here you can see now c.id, it is customer.id, c.name, customer.name, c.age, customer.age. Okay, then what you are joining here, that is o.amount. The o.amount is the orders from the order table you are taking. Okay, so how you are matching these two table, how you are joining these two table, c.id equal to customer id. Okay, so this is how you will write the simple HiveQL query for join operation, right? So first we'll discuss about the left outer join. Okay, so what do you mean left outer join? What is the right outer join? What is the full outer join? Okay, so in the left outer join, you will be taking two tables. So the first table you can consider as a left table, and the second table you will be considering as the right table. Okay, so here based on some condition, you are going to match these two tables. Okay, so these conditions can be, you know, any conditions you can have, right? So now when the condition is matching on the both the table, right? When the condition is matching on both the table, in the resultant table you will be getting the entire set of records that is available in the left table as it is, and what are the records are matching in the right table, only the matching records alone you are going to join. Okay, listen carefully. See here, at the time of left outer join, you are going to combine two tables. You are taking the left table and then right table. With some conditions you are going to perform the join operation. When the condition is matching, then you are going to take all the records that is available in the left table as it is. That is why we are calling it as a left outer join. Okay, then whichever the particular condition is matching with the record of your second table, that is in the right table, those table records data you are going to merge. That is, you are going to join with the resultant table. Okay, so the records that are not matching within in the right table, you are not going to perform the join operation. Instead, you will be making it as null. Okay, suppose if you are able to understand this concept, and understanding the right outer join and full outer join will be very, very easy, right? So here we'll just see the example now. So here in the left outer join, this is the query. Okay, similar to the previous one. Select c.id, c.name, o.amount, o.date. Those are the attributes or column values you are taking from the respective table from the customers and left outer join. This is the keyword you will be using to perform the left outer join. And orders O on, what is the condition? c.id equal to o.customer id. Okay, so here in this query, O is missing here, but this is actually the syntax. Okay, now to understand this left outer join more, we'll take a simple example here. Okay, so this actually left table and this is the right table. Okay, so in the left table you have two columns A and B, and there are set of data are available. Okay, so you have the three records in the left table and three records in the right table. Okay, so you have the A is the one, there are two attributes are there, A and B, and when you perform the left outer join, so let's see what is happening in the result table, right? So here you are taking 100, 101, 102. So all the values are present in the left table. Okay, you are taking as it is 100 database, 101 machines, 102 electronics. Okay, you are taking all the records that is available in the left table as it is. Then you are combining these two tables with some condition. Okay, what is the condition here? Course, that is whichever the data is matching with the A attribute, you are going to combine. Okay, so now the 100 is present in the left table as well as in the right table. So you are including 100 and Alex. Okay, the entire record you are going to join. You are performing the join operation, right, based on the condition. And then if you see 101 and then mechanics, see here you have the 101 here in the right table, there is no 101. Okay, the 101 value is not present. Okay, so what you are doing here, 101 mechanics, and here you are just making it as a null. Okay, in the right table you don't have the 101, so for that what you are replacing with at the time of join operation, you are performing with null. Okay, then you just look for 102. 102 is present on both the table. You are just again joining these two records. Okay, so 102 electronics and 102 Maya, right? Then the another question is, what about 104? 104 is present in the right table, which is not present in the left table. Okay, since it is a left outer join, we'll be seeing only the records or the data available in the left table. Okay, not in the right table. So 104 is not present in the left outer join, so just you are going to leave as it is. Okay, or otherwise you can just put it as a null, right? So in this way you can perform the left outer join, right? I hope you will be able to understand this, right? So the next one is the right outer join. It is just opposite to what we discussed now. Okay, so whatever you are doing in the left side, just you are going to keep it in the right side, and then you are going to make the null records in the left table, right? You can see here the right outer join, the HiveQL right outer join returns all the rows from the right table. That's what it is, all the rows from the right table, even if there is no matches in the left table. Okay, so there is one more question here is, if no record is matching, what will happen? Okay, so you just make it 0 or null. Okay, so if the on clause matches 0 records in the left table, the join still returns a row in the result, but the null in each column from the left table. Okay, so all the records, all the data which is in the left table will be made as null. Anyway, you will be getting the result in the result as your right table. Okay, so the query you can use in the right outer join, that is select c.id, c.name, a.amount, and then same thing, and you can see here right outer join orders. Okay, so this the keyword you can use in the query to perform the right outer join, right? So now so again same example, we'll take the same example, right? So the previous example, so whatever you have taken in as the input table, left table and right table. Okay, so this left table and right table you are taking as it is, and from this table just we are deriving this result, right? So when you perform the right outer join, what will happen here, right? So here 100 and 102 both are commonly present in both the table, database and electronics, and you are combining with 100. This is actually the right table attributes, and this is what your left table attributes. Okay, so the records that are matching for the particular condition on both the tables are present in the resultant table, right? So 100 database, 100 Alex, right? And then 102 electronics and 102 Maya, right? So here 104 we already said 104 is present in the right table, which is not present in the left table. So what you are doing here, 104 you are adding in the resultant table. This record you are adding joining in the resultant table, and whereas the left table content will be made as null, right? So you have 101 is present in left table, which is not available in the right table. So we are not considering this one. Okay, in the previous example, we just omitted the 104 completely, but in this right outer join, we are just omitting 101 completely. Okay, the 101 is present alone in the left table. Okay, which is not there in the right table, right? So you'll be seeing only the which particular join you are performing, that particular table only you are going to consider, and while performing the join operation based on the condition, then if the missing values are there in the other table, then those missing value will be made as null. Okay, if it doesn't matches, then you are going to say made as a null value, right? Otherwise, you are just going to perform the join operation, right? So now, so what will be the full outer join? Okay, the full outer join, maybe if you perform the left outer and then right outer join, if you are mixing up both, okay, so both the idea, so whatever we said for the left outer join and whatever we said for the right outer join, if you are merging both concept, both ideas together, then you will be able to get the full outer join. Okay, so here the HQL full outer join combines the records of both the left and right outer tables that fulfill the join conditions. You are picking up the records on both the tables. Okay, in the first left outer join, we missed the 104 record, which is available in the right table, and in the right outer join, we have missed 101, which was present in the left table. Okay, so those missing will not happen in the full outer join. Okay, so now let's see, right? So this is how you will write a full outer join query here, that is using the keyword full outer join orders. Okay, this order is the table name, so this is the keyword you will use, full outer join. But otherwise, the other conditions and the other attributes, everything is same, right? And so now you can see the full outer join. You have all the possibilities here, that is you are merging, that is you are combining both the table with the full outer join. So whichever the particular data is a record is missing, then that you are making as a null. Okay, so 100 database and then 100 Alex. So these 200 is matching on both the table, so you are having both the values or both the data in the resultant table, and 101 which is present in the left, which is not present in the right table, and in the right table what you are doing, you are making it as a null. Okay, then again 102 is present on both the table, so you are joining these two, that is 102 this record and 102 this one. Okay, then 104 which is present only in the right table, which is not present in the left table. When you are combining these two, you are making the left table as null, and then in the right table your data is there. Okay, so this is how you will perform the full outer join. Okay,
hey there, subscribe to my channel and also press this bell icon.